Hey y'all, so good news. This is our last lesson. I'll record a video and share Monday from me working the review for chapter 7, but this is the last new thing. And it's only kind of half new because you've graphed parabolas before. These parabolas, the ones that are y equals, it's just a quadratic equation, and you've graphed quadratics before. So all of this information you have found before. If it's a y equals and you have a x squared, you know it's quadratic. This is particularly vertex form, so I can pull out a vertex. I can label my axis of symmetry. I know whether it's going up or down. We can talk about whether it's narrow or fat. We can make a table, get some more points. You know how to graph. We've done this in this class. Back in chapter 2, 3, something like that. So what's new is that we're going to have x equals parabolas. So before we were concentrating on polynomials and functions and quadratics, and we could only have the up or the down because that's a function. Well, in conic sections, we're not talking about functions anymore because you think, well, we've graphed circles, ellipses, hyperbolas. None of those are functions. They don't pass the vertical line test. So when we talk about parabolas as a conic section, we get to turn them sideways. So we can have ones that look like this and ones that look like this. So that's when it's x equals and the y is what's being squared. Okay, so this is all kind of self-explanatory, I would think, because we've kind of done it before. But just to recap what this is saying, if you have this version of a parabola, it's either going to open up or down, and that's based off of this a value. If a is positive, we have a parabola that opens up. If a is negative, we have a parabola that opens down. You're going to get a vertex at hk, so the number with the x and then the number on the outside. Remember, change the sign if it's in parentheses. And then what's in parentheses will set up an axis of symmetry equation, the equation of the line that it reflects over. If it is x equals, then that a value being positive says that it goes in the positive direction on the x-axis, so it opens to the right. If a is negative, it's going to open to the left. And you still have a vertex at hk, but you've got to be careful. H and k have switched places because k is a y value. It's going to be in the parentheses with the y, and the h is the one that's tacked onto the end. All right, and then you know that as a gets bigger, your graph gets more narrow, and as it gets smaller, your graph gets wider. Smaller as in like a fraction. Okay, so a fraction less than 1. Sorry, my train of thought stops. Okay, so what was I going to say? Oh, you have a worksheet attached to this post, and it is your notes and your assignment. I don't really like the way the book handles this, so I put together my own worksheet, and then I just work a few of those as your notes, and you will do the rest of them as your assignment. So if you have a printer, you can go ahead and print it and work these problems on there, and you'll have the little graph available for you and all of that. If not, just like on your own paper, you can work the ones that I don't work and submit those to me. Okay. So we have an x equals, so that means we're either going to go to the left or to the right. I don't even know which way. I just pointed y'all, whatever. Since it's positive, we know it's going to go to the right. All right, so the vertex is going to come from this number and this number. Remember, with the y is the y, so that's the second number, the y coordinate. And this guy on the outside is going to be the x coordinate. So we have a vertex at 32. Axis of symmetry is what is in the parentheses. So it'll just be y equals 2. Again, remember changing the sign because the formula has a minus. So minus a positive 2. All right, so to get 2 other points, we're just going to make a table. Start with putting your vertex. And then remember that you are plugging in y's and getting out x's the way this one is set up. So we're going to pick 2 more y values, and we're going to pick 2 y values on the same side of our vertex. So you can either go 3, 4, or you can go 1, 0. It doesn't matter. They're reflections of each other, which we'll talk a little bit more about in a minute. So just pick 2 numbers on one side, and you actually will end up with 4 more points. Okay, so to get these x values, we have to plug in the 1, get an answer, plug in the 0, get an answer. So just in our head, we can do that. We can write it out on paper, or we can use the table feature of the calculator. Take your pick. All right, so if I plug in a 1, 1 minus 2 is -1. -1 squared is +1. +1 times 3 is 3. 3 plus 3 is 6. All right, if you're going to work it out, then all you're doing is what I just did in my head. I'm doing the 0 this time, but writing it out so you can see what's going on. So this is -2. And so then if you square it, it's 4. So you got 12 plus 3. So when we plug in a 0, we'll get 15. All right, so the other option is, now this says x equals, but if we just pretend like it says y equals, then we can type it in to our y equals. And so we can do 3 parentheses x minus 2 squared plus 3. Now, if I hit graph, this is not going to give me the right graph. It's going to give me an U that points up. But as far as my table is concerned, just keep in mind you typed it in backwards. So you're plugging in x's and getting y's in the calculator, but that's really plugging in y's and getting x's for your table. Again, doing it by hand is most of the time just as fast, and you don't have to think about all of the crazy that's happening. All right, so plug in a 1, you get a 6. Plug in a 0, you get a 15. So that saves you from having to do this, but you still have to think about the fact that you did things backwards. So whatever works best for you. All right, so when I say 2 other points, so on your test, when you have to do one of these, you're going to have to tell me the vertex, tell me the axis of symmetry, tell me 2 more points, and then pick the right graph. So when I ask you for 2 more points, I just need you to tell me there's a point at 6, 1, there's a point at 15, 0, what you got here in your table. Okay, so then to get a graph, we have 3, 2, and then that's going to be our axis of symmetry running through there. So there's this little imaginary line right here that we're going to be able to reflect over. So now let's go 6, 1 is here, and 0, 15 would be roughly here. All right, so remember there's this little imaginary axis. You can draw a dotted line in there if it helps you. So this guy gets a friend up here, and this guy gets a friend up here. And then we do the best we can to draw a parabola that goes through the points. That would be awesome. See if I can do it this way. Yeah, that's a no. Well, that's not too bad. It's a little. Okay, so that is the first example. All right, so let's try another one. All right, so this one is a y equals, so it's either going to go up or down. So looking at this first term, it's negative, so that means we know we're going to point down or open down, whichever way you want to think about it. The vertex is going to be -2, -4. So remember, you can figure out which number goes first by looking here. X is inside the parentheses, which means that that number is the x coordinate. On the last one, y was in the parentheses, so this number was the y coordinate. All right, axis of symmetry is what's in parentheses, or x equals the x of the vertex. Okay, and then to get 2 other points, we make ourselves a little table. So we have -2, -4 as the vertex, and we are plugging in x's and getting out y. So we're going to pick 2 more x values. Remember, it's 2 more in line on one side or the other. So if you want to do -3, -4, you can, or you can do -1, 0. It honestly makes no difference. Okay, so again, use your calculator or plug it in by hand or plug it in mentally, whatever works for you. So -1 plus 2 is 1. 1 squared is 1. 1 times -1/3 is -1/3. Minus 4 is -4 and a third. We put in 0. 0 plus 2 is 2. 2 squared is... All right, so again, I'm going to work this one where I show you all the ways, and then the rest of them I'm just going to do the one that makes me happy. So I talked you through it here, just thinking about it. Here we're going to write all of our work out. What did I just do? I don't know what I just did. This is... Oh, I'm plugging in a 0. I was thinking in my mind I was getting the same answer, but it wasn't working. I was very confused. Never mind. This is 4. Okay, so we plugged in 0. We got 2. We squared in, we got 4. Times -1/3, you get -4/3. Minus 4. So if you remember, -4/3 is -1 and a third. So if you subtract 4 from that, you get -5 and a third. All right, so if I wanted to do this with my calculator, this one we don't have to do things backwards because we are in the right form anyway. So we're going to say -1/3 and then x plus 2 squared minus 4. Then we go second graph. And we want to put in a -1 and a 0. And we get -4.333 and -5.333, which is what we got. Okay, so our other 2 points would be -1 and -4 and 1/3. And then 0, -5 and 1/3. All right, so to graph. Start with our vertex. -2, -4 is here. -1, -4 and a third is about there. And then 0, -5 and a third is about there. So vertex is here, the crazy point that I got on there. And these guys are going to reflect over. So he has a friend there. He has a friend there. And we do the best we can to draw a parabola. Okay, so I'm not going to ask you for this on your test, but let's go back to this one and talk about domain and range just so we can say that we discussed it. So remember, domain is left to right. So this one starts at 3 and it goes forever. If you think about the range, this is slowly going up and slowly going down forever, so it's going to cover all real numbers. All right, so if we look at number 2, this one for the domain, if you look at the bottom, it points down. So it starts at -infinity, and it goes to -4 as the highest point. And then the range... Yeah, that was the range. Some days I wonder about myself. Moving on. The range top to bottom was what I just did, y'all. Sorry. All right, and then the domain is left to right. And so that goes to the left and to the right forever, slowly, but it is. So it'll be -infinity to infinity. Okay. Moving on. What are we going to? Number 5. We're going to skip number 3 and 4. So 3 and 4 you have to do as your assignment. We're going to do number 5. So number 5 again is an x equals, but if you see here, there's no parentheses squared. Well, that means you have to complete the square, which takes us to our attendance question. So it's been the same question for every video. How do you look at a general form and know that you have a parabola, a circle, an ellipse, a hyperbola? So we said, and you're going to have to be able to do this on your quiz, so I'm recapping all of it to make sure you're listening on your test. For a circle, you have an x squared, a y squared, added same coefficients. For an ellipse, you have an x squared, a y squared, added, but different coefficients. Hyperbola is an x squared, a y squared, subtracted. Coefficients don't matter, they can match or not. For a parabola, you only have an x squared or a y squared, not both. Okay, so we know we have a parabola because we only have one thing that's squared. And then to get ourselves in the right form, we're going to have to, you guessed it, complete the square. All right, so we are going to handle things slightly different in one aspect, so make sure you're listening. We're going to take these two y's and factor out to the 2. And put a plus blank to complete the square. We're just sliding the 10 over because I need them to stay on this side. And then to counteract this, since they're on the same side, I have to do a minus blank. In all of the other ones, we were trying to get that constant to the other side. So we would move it over and then we would do a plus blank on one side and a plus blank on the other. With a parabola, you're keeping everybody on the same side. So you're just sliding that constant over and then putting a minus blank to counteract the plus blank that you have earlier. Okay, so the completing the square process is the same. We're going to call this y minus 2 squared. That's our goal, is to get that to factor to y minus 2 squared. And we accomplish that by putting 2 squared or 4 here. So half of 4 is 2, 2 squared is 4. Remember that you have to think about the fact that this is in parentheses multiplied by a 2. So over here, we're actually putting an 8, which means we have a plus 2 on the back. All right, so direction of opening. We are in x equals, so it's either left or right. Positive here means to the right. The vertex comes from this number. This number right here is the y. And so that makes this the x. All right. Axis of symmetry is in the parentheses. So y equals the y of the vertex. All right, so then 2 other points. We're going to make ourselves a little table. So our vertex is 2, 2. We're plugging in y, so we're going to pick 2 more. So we can go 1, 0. We can go 3, 4. All right, I'm just going to mentally do this unless something gets difficult for my brain this early in the morning. Let's see. We plug in a 1. 1 minus 2 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 plus 2 is 4. Plug in a 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 plus 2 is 10. So the other 2 points we're working with are 4, 1 and 10, 0. And then they're little reflective buddies. All right, so 2, 2 is the vertex. Then we need to go 4, 1. And 10, 0. Remember, our goal is to go like this. We have this little axis of symmetry running right here. So he gets a friend up here, and he gets a friend up here. And we do our very best at making a parabola. Our goal when we draw these, y'all, I know perfection is not something that any of us have in the artistic realm. Some of y'all are good artists, but you don't graph awesome. Some of you make really pretty graphs. Anyway, some of us just can't draw and can't graph, whatever. So try not to have it too squiggly and make sure that it's rounded through the vertex, not pointed through the vertex, and I will count it as perfect. All right, 2 more. Number 6. All right, so here we know we have a parabola because x is the only thing that's squared. There's only one squared term in a parabola. It can be the x or the y, but only one of them. All right, so when it comes time to write it in vertex form, we need the not squared variable. by itself. All right, so this is my goal, is to do that. Let me rewrite this so I don't lose anybody. All right, so I want y by itself, which means this has to move over here with the x, but I'm kind of switching them as I write them down because I want it to say y equals. So x squared is going to have a minus 2x because I moved it to the other side of the equation. And then add a 5 over there. But then I like switched them so that y was first. Okay, so now to complete the square, there's nothing to factor out, so it's just x squared minus 2x plus a blank. I'll put parentheses just so you can see that that's the completing the square piece. Plus 5 slid over, and you need a minus blank to counteract this plus blank. And again, parabola is the only time you do that, and it's because everybody's staying on the same side. All right, so factored form is going to be x minus 1 because half of 2 is 1 squared. Plus minus, we're not sure about that. I bet it's a plus, but we'll leave that off right now. Okay, so 1 squared is 1. Nothing out here to multiply by, so 1 goes here. This becomes 4 because 5 minus 1 is 4. All right, so we are y equals, so it's either up or down. It is positive, so it's going to go up. All right, the vertex is 1, 4. And we know it goes in that order because this is an x, so this is an x. Axis of symmetry comes out of the parentheses. Sorry, y'all. To get to other points, you're really just making a little t-table. You have an x having stuff done to it, so you pick 2 more x values. So I'll go 2, 3. All right, so plugging in a 2. 2 minus 1 is 1. 1 squared is 1. 1 plus 4 is 5. 3 minus 1 is 2. 2 squared is 4. 4 plus 4 is 8. All right, so 1, 4 is the vertex. So there's like a little imaginary axis running here. And then 2, 5, and 3, 8. So we're curving down, so we got to curve back up, right? And there's an axis going here. So he gets a reflective buddy on this side, and he gets a reflective buddy over here. And then we draw something that resembles a U. Okay, so one more, but this one's not actually from your worksheet. It's one that I made that's like it because there's only one like it on there, and I wanted you to try one that looked like it. So this is like number 9, but not the same as number 9. So you're going to have to do, we just did 7, right? So you're going to have to do 8, 9, and 10. So what was that, like 3, 4, 8, 9, 10, 3, 4... 7, 8, 9, 10. Okay, so here we go. So looking at this, you see how the y is being squared and the x is not. So you still know you have a parabola because only one thing's squared. We want this to stay intact. We need the x by itself over here. All right, so to get x by itself, you have a couple of options. For some reason, like in middle school, y'all are, I know what the reason is. I just had this conversation with Lane the other day. In middle and elementary school, they kind of only give you one way of doing things so that you don't have to think too much about when's the best time to use what. And so they don't necessarily tell you like the shorter way to do things. They just tell you the way that always works. So most of you look at this and think you have to distribute. Well, you really don't. If I'm trying to get x by itself, I can divide first by this negative 3. So when I divide on this side, it becomes negative 1/3 times all of this because we don't really want it to say all of that over negative 3. Here they cancel and you're left with x minus 5. And then you just need to add the 5. And again, I'm going to switch. So I'm going to say x equals, and then this stuff with the plus 5. All right, so if you were going to distribute, then you would be subtracting a 15, and then dividing by negative 3. So it's like one more step. You distribute, then you move the constant, and then you divide by the coefficient instead of it just being 2 steps. So anyway, either way works. I just wanted to make sure that y'all knew that you could do that. Okay, so this is an x equals. So it's going to go left or right. And it's a negative, which means it's going to go to the left. So it's going to open like this. The vertex is going to be 5, 4. And again, I know that it's that order because 4 is a y. So it's got to be x, y. So 5, 4. Axis of symmetry is going to come out of here. So y equals 4. And then we need to make a table. Oh, that was supposed to be a y. All right, so 5, 4 is the vertex. We are plugging in y's. So we're going to pick 2 more here. So we'll go 3, 2. All right, so if I put in a 3, 3 minus 4 is negative 1. Negative 1 squared is 1. 1 times negative 1/3 is negative 1/3. Plus 5 is 4 2/3. I know y'all struggle a little with the fractions. Hopefully you're okay with 5 minus 1/3 is 4 2/3. All right, so plug in a 2. You get negative 2. 2 minus 4 is negative 2. Negative 2 squared is 4. 4 times negative 1/3 is negative 4/3, or negative 1 1/3. And then we're going to add 5 to that. So it's really 5 minus 1 1/3. So that takes us down to 4 minus 1/3. So 3 2/3. Okay, so plotting our points. We have a point at 5, 4. I don't like getting this close to the camera, y'all, but I can't see my screen. So what's our next point? 4 2/3 and 3. So 4 2/3, 3 is going to be like really, really close. And then we want 3 2/3, 2. So, oh, y'all, that wasn't 4. That was 3 2/3. Oh, no, it's not. I'm really losing my mind. 4 2/3 and 3 is here. Now we're going 3 2/3 and 2 is here. Okay, so go back up here and realize we're going to the left. We have an axis of symmetry at y equals 4. So we have this axis running through here. We need to make a picture that goes like this. So give these their reflective buddies. And then draw a picture. Something like that. Okay, so there is some examples of graphing a parabola. I tried to keep it like kind of in the realm of everything you're already aware of and not giving you anything new. Parabolas have something called a directrix. And again, just like with foci, if you run into in the future where you need to know what that is, please email or call me at the school. Hopefully we're back there by the beginning of next school year. And I'll be happy to walk you through anything you need to know about conic sections that I didn't cover, all of the foci and directrix and things like that. My goal with this was for you to be exposed to them, know what they are, be able to get a picture, be able to recognize when they're in general form, just kind of the basics, because a lot of you will never use it. So if you are somebody that is going to be taking like some engineering maths or calculuses or things like that when you're in college, then seriously, I'm happy in the future to help you. If you run into some things that I mentioned but never really explained, call me and I will explain them. Okay. You'll get a review Monday. We'll test on Wednesday. I will also on Monday send out your final review so you can go ahead and start working on that. It will be due on the following Monday, May the 4th, when you take your final. And I don't want you to stress about that final because in the past, people have done very well on it. So I really think you're going to be okay. And I've changed some of the ones that weren't multiple choice in the first place to multiple choice because it's hard for me to grade graphing on a test. So I didn't do any where you actually had to graph. You have to pick the right graph. So anyway, that's it. Y'all have a good weekend.